Okay, so let's just summarize what we've done today. So the idea was that we used this Euler's method to solve the equations of motion and to solve for the motion of an object, also with including air drag. So to summarize, you could make your own worksheet by clicking here up in the left, and then using the worksheets that were already made, the theory. So you will go to published and then theory, and you can find all the theory that we used in here, and also an example program. So let's just copy this example. And one thing I wanted you to do, so let's make an example worksheet, was to take this this example program and run it for various angles. So this is a baseball that is batted at a given angle, and this angle here is right now it's pi/6 because it's radians. You can of course change that by giving it in degrees by writing. Oh right, you have different keyboards here in. Okay, so you can change this angle by simply deleting the previous one and inserting the new one. So we want this this angle to be the same. So what I'm going to do right now is I'm going to write it as a different variable. So let's see here. And I'm just going to input the angle here. So and then by rerunning the program, we get new results. So that's by clicking the evaluate button, we get a new plot. But so to compare this for various angles, you can just change it and rerun it. But the problem here is we have a hard time comparing if they're in different figures. So what we're going to do now is we're going to use a loop to plot all the different angles at the same time. So first we have to look at our program and look at what actually changes when we do a new run. So if we start at the top, nothing of the physics changes. So these parameters, the constants, they don't change, and the force doesn't change. And all of this time doesn't change. What will change if we change the starting angle are these arrays. The position and velocity and acceleration are going to change. So, and also these initial conditions are changing. So what I'm going to do now is I'm going to take all the code that we repeat. So that's creating the empty arrays, setting the initial conditions, solving the equation, and plotting it. I'm going to do all that repeatedly. And to repeat that, I'm going to go in and I'm going to press tab, and the tab is the button on the left hand side of the keyboard.
Including plot results?
Including plot results.
So from create empty 2D arrays to the end?
Yes. I'm not going to, these last things in the plotting is just to prettify the plot, so I'm not going to do those repeatedly. But everything from creating the empty arrays down to plotting the results. I mark all that with my cursor, and then I click tab. And then when I click tab, what happens is it jumps in. And the reason I do this is because what I'm going to do now is I'm going to make a new loop. And I'm going to say for angle in, and I'm going to make a list of angles I want to do. So I'm going to do pi12, pi6, pi4, and pi3. So that's radians, and that's let's see, it's 15, 30, 45, and 60 degrees. And then I'm going to end with a colon here. Let's see there. So with this line, I repeat all the code that I tabbed in. So for each angle, we're going to create empty arrays. we're going to set the initial conditions, and I need to remove this line because the angle is chosen up here. So first the angle is pi 12, then the angle is pi 6th, then the angle is pi 4th, and then the angle is pi 3rds. And for each of those angles, we create empty arrays. We set the initial conditions, we solve the equations, and then we extract and plot the results. And this line is very important that we remove because the figure, since it's an empty figure here, it deletes the old plot, and we want to include all the plots at the same time. So I'm just going to remove this here. And so effectively what I'm doing is I'm looping here in a for loop, and the angle is looping over these 4 various values. And in each case, I create the empty arrays, I set the initial conditions, solve the equations, extract the coordinates, and plot them. And then once I've plotted everything of that, I've done all that, now I have all the plots, I'm just going to label my plot, insert a grid, insert a title, and show it, finally. So once I've done this, I am ready to evaluate my program. And we see that, well, we have various curves here, but the problem is I'm cutting my figures so I can't see them. And the reason I do this is I have this axis commando, which chooses how big my window is going to be. And previously, I used this window because that showed my figures. Now I have to guess, maybe twice as high. So I'll plot for the same, 0 to 110. But this time, instead of 20, I'll try 40. So this is just trial and error until I get a plot I'm happy with. So it's still a bit low, so I'll try 50, I guess. And this is just trial and error. And I'm just going to keep doing this until I get a result I'm happy with. So this is pretty good. Pretty happy with this. So in this case, it's very easy to see which angle is which, because you can see it from the beginning. But in some cases, you plot various lines which you can't really see just from the curve what you're looking at. So what we're going to do is we're going to use a command called legend. We can't have the tab there. And legend is just going to tell us what the various angles are. So, this is... So in my loop, I go pi 12 is the first, so that's 15 degrees, and then 30, and then 45, and then 60. So in the legend, I write them in that order. And 30 degrees, and 45 degrees, and finally we have 60 degrees. So if we plot that now, hopefully we will get, yeah, and just the colors are wrong here, and that's because we need to, before we do any plotting, we need the figure command, which I removed earlier. So I'm just going to put that there instead. That's because we want to start with an empty plot. And there, now we have reached our final result. And we can see that we have our 4 angles here. We have 15 degrees on the bottom, 30 degrees, 45 degrees, and finally 60 degrees.
Where did you, sorry,
Yep.
how did you pick the legend?
The colors, you mean?
Yeah.
Yeah, I just, the thing is, since I removed the figure completely, it was drawing lines over lines.
Yep.
So the colors are messed up. So I just included a figure before the for loop. Because if you have it after the for loop, you erase your hard work. So you want it before the for loop. Yeah. Yes, and that is one example of how we can use these programs to calculate different things.